Let's just remind ourselves with water, which is one that is pretty straightforward. So the subscript on H2O means that in 1 mole of water, there are 2 moles of hydrogen atoms and 1 mole of oxygen atoms. So let's review that real quick. If you had 1 single molecule of water, it would have 2 atoms of hydrogen and 1 atom of oxygen. If you had 1 mole of water, which is more reasonable, you would have 2 moles of hydrogen atoms and 1 mole of oxygen atom. So 1 mole of water molecules has 2 moles of hydrogen atoms and 1 mole of oxygen atoms. I look on the periodic table of the elements and find hydrogen, which is 1.008 grams per mole, and oxygen is 16 grams per mole. When you type those into your calculator, you're going to get 18.016 grams per mole. Now remember our rules on sig figs. This number is 3 past the decimal. This number is 2 past the decimal. So if I was reporting this measurement, I would report it as 18.02 grams per mole. That would be the answer if it asked for the molar mass of water. But I'm going to teach you how to do percent composition. So percent composition is, what are these things made of? So the percent composition of water would be calculated as follows. It is the part over the whole is the general formula for percent composition. We know to turn it to a percent, we multiply by 100. So the percent composition of water consists of hydrogen. We would calculate this by the part that's hydrogen over the whole water molecule. We have to be careful because there's 2 hydrogens, so it's not 1.008, it's 2.016 grams of this compound is hydrogen out of the entire 18.016 grams. Now, when you're doing these problems, this is the part that everybody forgets. You're going to use your raw number. You don't want to use your number that you rounded. You only round at the end of a problem. So you want to use your raw data when you're doing calculations. So I get that this compound is 11.919% hydrogen. The other part is oxygen. So the percent composition of oxygen would be, what part of it is oxygen out of the whole water molecule? So 16.00 grams oxygen out of 18.016 grams of water. And I'm going to get 88.81% oxygen. Now I can check if I've made a mistake by adding up the percentages. If I've not made a mistake, what should those percentages add up to? 100. And in this case, it adds up to exactly 100%. So we're good to go. You guys have probably been doing percents and stuff like this in math class for forever, right? Okay, I'm going to do one more example that has 3 elements in it, and then I'm going to see where that takes you. Let's do calcium nitrate, which is a salt. can be used as ice melt. Do you guys have ice melt at your house at all? Pretty apropos for tonight. If you guys think of it, take a picture of the ingredients in your ice melt, because we always use salt to melt ice. But salt is not always NaCl. That's table salt for us, or another term for it is rock salt. Table salt you would eat, rock salt you would not eat, even though it's NaCl. It's not food grade NaCl. So you don't just eat stuff, right? What happens is, the reason that we use salt to melt ice is the fact that this compound is an ionic compound made of formula units. And in each formula unit, you have 1 calcium and 2 nitrates. So we have a total of 3 ions in this compound. Those ions get in the way of the water molecules and keep the water molecules from freezing. This is called freezing point depression. They also do exactly the opposite for boiling point elevation. So have you ever made pasta at home and your mom might have told you to salt the water? You're not doing that for taste. The reason you're doing that is because it makes the water boil at a higher temperature. So the reason that you use ice melt instead of salt is because, like the rock salt's a little hard on your concrete and your asphalt driveways and stuff. So tend to buy ice melt for our houses because it's a little bit better for everything. When you go down the street and you see those big, giant snow plows spewing salt everywhere, that's usually rock salt, because it's cheaper and they want to do things cheaper. And they don't care if it ruins the roads. You'd think it would be cheaper to buy the right ice melt than it would be to keep fixing our roads, but here we are. So in this compound, you have 1 calcium and you have 2 nitrogens. And let's be careful, because this 2 belongs to nitrogen and also oxygen, but don't make the mistake of thinking it's 5. It's 3 times 2, or you can count them up here. It's 3 plus 3 is 6 oxygens, like such. I look on the periodic table of the elements and find the individual masses of calcium and nitrogen and oxygen. Remember, because of sig figs, 16.00 is not the same as 16, so we do not drop those zeros. They are significant and they matter. Your calculator is going to tell you 164.10 grams. All of these have 2 past the decimal, so our answer will have 2 past the decimal. Now let's do the percent composition. The part that's calcium over the entire molecule times 100 . And when you plug that into your calculator, you're going to get 24.24% rounded to 4 sig figs. Percent nitrogen would be 2 times 14.01, so 28.02 grams over 164.10. Multiply it by 100 to turn it into a percent. And then in your calculator, we're going to write down what the calculator tells us in its entirety. It says 17.07495543 We know that if I'm going to report this answer, I'd need to round it to 4 sig figs. These are my 4 sig figs. Notice this is 0.49. So close to rounding up, isn't it? But we're going to round it down because it is less than 5, 17.07%. I want you to pay attention to this one because you'll see that we rounded it because we do need to report our answer in 4 sig figs, but when I go back and check that it adds up to 100, it's not going to quite add up to 100, and that's okay. The part that's oxygen is 96 grams, or 6 times 16. And I get 58.50%. So now when you add those up, you're not quite going to get exactly 100. That's because we did a little bit of rounding. So if you add them up and you get either like 99.99 or, oops, I imposed these, sorry. I do this all the time. This is not 24.24, it's supposed to be 24.42. Sorry about that. So when I add these up, I'm going to get 99.99% instead. And we need to recognize that that's close enough to 100 that we would consider ourselves correct because there is a certain amount of rounding involved, and that rounding leads to numbers that might be a little off, but still close enough to be correct.